Yeah, that's because did you see that on the?
Yeah, you watched that one too. Hey, good morning, everybody. We're on our topic 8 this week. We're going to be talking about web scraping. There's a few files that will be useful for you to have in class today. The first one is this notes.py right here. That's what the main thing that we'll be going over today. And the second one is this Dracula.html, which if you already have started or completed the Dracula lab, then this is just that same file that's been downloaded from Project Gutenberg. And we're going to be doing some different stuff to it unrelated to the lab. So this notes.py is the most important one to have, and then this Dracula.py, a second one that will be used by this notes.py. While you're all downloading those things, so today, the technical things that we're going to be talking about, we're going to start talking about web scraping, which I think is going to be one of the more fun topics that we've talked about so far. Basically, everything that we have left in this class is all super fun stuff, I think, that up to this point. So I like this analogy of thinking about Python as like or learning Python, learning a programming language as like learning a human language. And at this point, we've basically learned all of the grammar there is in Python, all of the like, I don't want to say boring mechanical stuff, but less fun mechanical stuff. And now we get to focus on like all the really cool applications at this point going forward. Sort of like if you're thinking about learning a human language, you actually get to learning about the culture of whatever group of people you're learning their language of, or like read their famous poetry, or start writing your own cool things. And so yeah, we're in that cool segment, the actually doing fun stuff part now. Again, it's this notes.py file and dracula.html that you'll want to have access to for today. And then still, before we get into the technical stuff about web scraping, it's a little bit, it's about halfway through the semester, a little bit more, so I thought it'd be a good time to talk about how the class is going overall. So the first thing is that everything is graded and updated in Sakai, so everything that you've submitted so far has been graded, and the grades are all exceptional. Very happy with everybody's performance so far in this class. One sort of like warning caveat is that historically, this project number 2 has been a pitfall for students where grades, people often don't get the grade that they want on project number 2 because they don't really read the directions very closely. And so definitely don't let that happen to you. Make sure that you actually complete all the things that project 2 is asking for, and get full credit on it. Yes, question.
In project 2, it says that like on the x-axis, like all the data range that's included in like the data set should be included. Is it okay if we exclude like one data point because it only has like half data for half the year, because that would mess up the averages that it's trying to show?
Yeah, so the question is essentially there are a bunch of like particular requirements and that I'm asking you to complete on project 2. And is it okay in certain situations to ignore those requirements? And the answer is that what you should do is you should do the thing that makes sense for the data. You definitely will not get docked points if you do whatever's listed as the requirement. But if you think that the requirement shouldn't apply to you for whatever reason, then you can take a gamble and not do it, or you can just show me like beforehand and I'll say like, yes, this is full credit as is, or no, you actually need to do this thing. Good question. Any other questions on the project? Yes.
My Wi-Fi is working, so I can't pull up the exact thing, but there was one project that said like compare two different data. So like so we have two data sets. We picked one CSV, one JSON, and then but one of them says to compare two data sets. So that like within either the JSON or CSV that we pick, also compare to another thing in that file.
So you need to have two plots. One of, as in two images. One of those images just needs to have a single thing drawn on it. The other thing needs to have two things drawn on it. Those two things can come from two different files, one file that's processed in different ways. But it's a like a matplotlib requirement that just figure out how to use matplotlib to get two things plotted on one picture. Good questions. Any other questions about project number 2? Okay, again, office hours tomorrow. If you're collaborating with somebody, then you would be able to visit those office hours and just like actually show me, here's your project, and I can look at it in 20 seconds, tell you that exactly what your grade's going to be. And so if you're not 100% convinced that you have a full credit submission, then my recommendation is to show it to me, and I'll tell you exactly what your grade will be before submitting it. Okay, other things to highlight or to remind us about teaching philosophy things. So in general, when learning a programming language, my philosophy is that the best way to learn a programming language is the same way about learning a human's language. So again, immersion. So even if you don't fully feel like you're 100% comfortable with all the sort of grammar things that we've talked about at this point, that's okay. That's an appropriate place to be at this point. That as we see all these other cool applications of things, that'll make things like all the different for loop patterns and creating functions and all these other things more clear as you see these examples. And again, I think I don't know, one of the maybe traps, one of the pitfalls that students fall into, not just in intro programming courses, but an entire sequence of CS classes, is that you feel like that it's good to know everything. It's good to feel like you're in a place where you know how to do everything. And if you are in that place, then it means that you're not going to succeed out in the real world at a job, because professional programmers never know what we're doing. That's what makes the job fun, is that we don't know what we're doing. And so it's always this we're always in this state like this dog here at the computer, just racking our brain. And then eventually we get it to work and we feel like a god. But this is only 1% of the time over here and 99% of the time over here. And that's true of everybody, not just beginner programmers. Another thing is that, so assignments should not be busy work, but actually help you to get a job. That's one of the things I feel very strongly about. And so occasionally, well, very often I show, in this particular graph, I show it to my colleagues in the math department here at CMC, or to other CS professors at other schools. And I'm bragging about how well you all are doing to them. And their first response is that, wow, your students, the grades are too high and you should give them more work to lower the grades. And I think that is an awful thing to do. I think the grades are high because you all have earned them, and you should be rewarded for that, not punished for that. So if you've never heard of Betteridge's law of headlines, that's the law is that anytime there's a yes or no question on the internet, the answer is always no to that. And so I'm not going to add more work to this course to make it harder, to make it artificially harder to bring down those grades. Because again, this hacker philosophy of boredom and drudgery are evil. And so I've really done a lot of work engineering the class, designing the class, so that there is a lot of work in this class, but it's sort of the minimum amount of work to actually get, so that you actually learn the necessary material. And not a whole bunch of busy work, because that is evil. So a lot of these projects that we're doing are different than projects in other classes, especially like say CS5 at MUD, and that we're doing things a lot with GitHub, getting our projects online. And again, for your project 2, this is an example of that. That's you're like I am in some sense the audience for your project 2, for these graphs that you're generating and putting on GitHub. But these graphs are going to be available for everybody on the internet to see, including your future employers. And so in a bigger sense, like I am not the most important audience for these projects that you're doing. It's your future employers, future colleagues, other people on the internet who you just want to show cool stuff to. And you should be working on these projects in that sense. So here's a quote from Google's HR chief. His name's Laszlo Bock. He said that we did a bunch of analysis and found that grades are of little predictive value or they have a little bit of predictive value for the first 2 years, but for the rest of your career, they don't matter at all. And so Google, like historically, has never looked at GPAs when they're hiring people. It's the same for other like top computer science or data science companies. And so I just went to this conference in Korea. One of the things that I do at these conferences is I talk to people who are hiring managers at a bunch of different companies. And I asked them this time, is this still your philosophy that you don't care about GPAs? And unanimous answer is, we don't care at all about GPAs. The hiring managers so I talked to hiring managers at Google and Amazon and a bunch of Korean employers. And they all said that they don't have access to that information when they're making their hiring decisions. And if they did have access to that, they wouldn't look at it because it's just not helpful. So instead, what are the things they look at? They look at like, what are the actual projects that you've completed in the past? So things like they'll look at your GitHub repositories, see what have you actually done. And since our class is putting stuff up there, you'll actually have stuff to show them, whereas other students won't. So that'll put you ahead of the game on that. Okay, that's just, I don't know, background material, why the class is structured the way it is, before we get into the actual technical stuff for today. Any questions about anything administrative wise before we get into web scraping today? Okay, so the notes.py file. I have it opened in VS Code over here. Again, it's under the topic 8 folder. There's this notes.py. And anytime we have a Python file that we're going to be looking at, the first thing that we should do is just run it and get it to work. So we'll start this off, run it. Let's get this thing out of the way over here. And oh no, we have a file not found error down here. In order to figure out what line this is happening on, we always start from the bottom of our error message, go up to the top. And so here is the name of my file on line 13. Let's find line 13. Okay, it's right here. And it's on this open function call. Again, we have this file not found error. I'm pretty sure that there's this Dracula.html because I can see it right here. So anytime we have this error message, one of the key things to remember is about the path that you're currently working with. And so my current working directory, my current path is this CS40, but all my files are inside of this topic 8 folder. And so if I want to be able to actually open this, then I need to change my working directory CD into topic 8 like that. Again, I was pressing tab to make that typing faster. I don't want to get carpal tunnel. I don't want to waste my time. That's like 10 seconds typing all that. Ugh. So just press tab and it completes it for you. And now that I am, my working folder has those files inside of it. If I press the up arrow to get back to my previous command, where did it go? There it is. Then I can press enter and it's not gonna do anything. It's gonna take a while like this, but then it finishes. And let's see, 26. This since we're web scraping, we're going to need internet access today. And so hopefully the internet is going to cooperate. But this is an error message about the internet not cooperating. We'll get to that later. As long as your code is getting past line 14 here, let's try one more time, then you're good. Okay, so far we've seen two different ways of getting information into your Python program somehow. So loading text. Text is sort of like the simplest, most prototypical example of information. And our first way, the first way we've seen is just like typing files or typing a string in by hand. And we call this a literal string because it has this quotation mark inside of here. Anytime you have the quotation mark, it's a string literal. And anytime you have something that you want to be a string in Python, you have to include the quotation marks around it to make it the string literal. Then this works for very small strings, but if there's a larger string that we're trying to get access to, like the contents of a book, well, that's too much to try to copy and paste it into our file. And we also have this philosophy in hacking that we don't want to have to solve the same problem multiple times. So we want to make our code sort of generic so that it can work on many different kinds of text, and then we just load that text in at runtime using our files like this. So this is really the only way we've seen so far for loading large files. And again, we talked a lot about the different types of encoding, and the takeaway message from that was that anytime you're opening a file for whatever reason, you should specify the encoding, and 99% of the time, UTF-8 is what you're going to want. Today, we're going to talk about two more ways of getting string information into Python. And the first one is this requests library right here. Requests will download things from the internet, and request is not a built-in module, so you'll have to install it using the pip command, whatever that looks like for your computer. And again, since this has a $sign right here, I know that I'm typing it into the terminal down here, something like pip3 install requests. But exactly what that command is going to be different for every computer, and it's however you installed the YouTube download or any of the other libraries that we've worked on so far. Yes?
It says it should be upgraded. There's a new release available.
If it's talking about upgrading it, then don't worry about it. You can if you want to figure out what the invocation is for that, but you don't need to. We're not going to use anything remotely fancy about these libraries that require the newer versions. And here what I have, so this is a string literal right here. This is a URL that contains a link to the over here. Paste that URL. It's just a link to the Project Gutenberg Dracula page. And so this is exactly the same contents as the HTML file. It's just on the internet instead of on your hard drive. When we actually get the contents of this file, then we will be able to access it, do things with it the exact same way we would do things with it as if it was loaded from the hard drive. So since we're getting an error message when I run this, let's see if we still get an error message. Yep. Let's open up interactive Python and we'll work through this and figure out exactly what's going on here. So interactive Python, Python 3 like this. And then I'm going to import requests down here, copy and paste this URL like so. And then do the r equals requests dot get of URL like this. And all the there's a couple of references that you can use to find out more details about the requests library. It's in the textbook in chapter 12. They have a whole chapter just on web scraping. And then there's this a link to realpython.com, which has a little bit more updated, more advanced, more modern take on web scraping with this requests library. And then we'll talk about what this HTTP status code thing is later. But these two links here are the main links for working with requests. And now, so this R object right here, let's do r.text. That, and okay, we get a bunch of text printed out. It looks like somehow I accidentally added a 1 to the end of this. What we want is just text like that, no 1 at the end. And the text right here is the actual like text of the web page located at this particular URL. And so just looking at the output down here, I see a whole bunch of things that look like HTML. And I see things like Project Gutenberg in here. Here's a link to gutenberg.org. So it looks like this is HTML. It looks like it corresponds to this web page right here. So again, I had a typo. Somehow I added a 1 to the end of here. It should be just r.text by itself like that. And these 3 lines is all you have to do, or I guess these 4 lines is all you have to do to get the contents of any URL on the internet. You can download it and then process it in Python. Any questions about these 4 lines right here? Yes.
Like, so import request is for this, have to play the other one, but not like define request.
So sometimes anytime you have one of these libraries that you have just recently installed, the question is that there was a yellow squiggly line below this requests right here. That yellow squiggly line means that VS Code isn't yet aware of that you have installed this. And so it might take a minute or 2 for that to go away. But if you actually run the program, it should work after you've done that pip install command. Okay, we'll talk more about this requests library, sort of the ways that it can go wrong in a little bit. But at this point, this is just like the ways that it can go right. And we'll leave it at that for now. Question?
Where do you define text?
Question is, where did we define text? And the answer is that text is not defined anywhere. That on each one of these little methods I have, there's text1, then text2, and then text3 down here. There is no variable called text. Anytime you see we call this an attribute in Python, something to the right of a dot, it means that this was defined inside of this thing to the left of the dot. So down here, if I did type of R, that'll tell me like what is the type of R. It's something that's built into this requests library. It's a requests.models.response. And yeah, we don't need, at this point, we don't care about how these things are defined. We just need to know that this R has all the information about what is contained at this web page. And if in particular, I want the text of that web page, then r.text will get it for me. If instead of R over here, another thing that you'll sometimes see in tutorials is response. So that R was short for response. So then it would be response.text will get me the contents of this web page up here. Good questions. Any other questions? Yes. So the question is, we're getting an error about opening the Dracula file somewhere on these lines up here. And the answer is that anytime you're having a error about opening a file, then what it means is that somehow whatever you're passing as the file name to the open function, Python is not able to find it. And so it's possible that you have a typo up here that doesn't match what the name of the actual file is on your hard drive. It's possible that you don't have the file at all, that if you didn't download this file, then it's not going to be there for you to find. But the most common problem is that your path that you have downloaded this file, it is named the right thing, but you're just not looking in the right location. That your default location where you look for files is your present working directory. And in order to make Python look in the correct folder, in my case, I downloaded it into this topic 8 folder. We have to change my working directory into topic 8. And now my working directory matches the location of the Dracula's file. And so now when I run it, it is not going to give me an error. It's not going to give me an error here because the path is correct. And it's now not giving me an error down here because I fixed the typo, removing the 1. Okay, so we're gonna talk here in a little bit about what you can do, or we're gonna do interesting stuff with the contents of this URL or the contents of this file here in a minute. But before we do that, I want to see one more method of getting text information into Python, and that is this argparse library. Argparse is something that is built into Python, so you don't need to pip install anything. And these 5 lines right here are just the sort of standard way of putting argparse into your program. And actually, I'm going to change this text one just to text as well. The way argparse works, so again, the command line is this thing down here. The way argparse works is if I write Python 3 and then notes.py like this, then -- text equals, then whatever I put in this quotation marks here after the text is what's going to be in this args.text variable right here. So it'll be equal to text4. At this point, if I put something in here like hello world, then it's not going to be, I need to save that. Again, I removed the 1 from this and removed the 1 from this. Up arrow, rerun that. It's not doing anything with this information right here. So I'm not going to be able to see that this information has been passed into Python. So let's go ahead and add a print statement real quick. Text4 equals text4 like this. So this text4 is coming from this args.text. .text over here is what's going to be, it's going to contain whatever is inside quotation marks to the right of the equal sign of this -- text. And so we'll print out text4 equals hello world. If I change that to be bold HTML/bold like this, then it'll contain that HTML right there. If I change this parser.add argument, add another thing, so text and example, then down here, print args.example equals, args.example. And now down here, I can also pass in example equals goodbye. And whatever I put in for the example right here got put into the args.example variable and printed right here. So this interface might look a little bit familiar to you from the Markdown compiler's assignment, that you didn't have to interact directly with this argparse library, but you did have to use things down in this command line. And similarly for the YouTube download, you did have to use things in this command line. And in general in Python, it's very common to have commands that you'll be using that interact with this command line. And all of those commands in Python, the way that Python's getting access to whatever the text is down here is through this argparse library, and then somehow doing args.text to get the -- text input, or args.example, or args.whatever input you have down here. The main takeaway at this point is just that there are many, many different ways of getting text somehow from outside of Python into Python, that you can use a file, you can use the internet, you can use this command line down here. But whenever you do that, you're always going to get text as output. You're always going to get a Python string that we can manipulate with all of our Python string operations. Is there a question, Freya?
Yes. For the args.example,
again, like, so we don't have to define argstat.
Yeah, so the question is, this args.example, we didn't define it anywhere. Where exactly is it coming from? That we defined the args thing. We always have to define the thing to the left of the dots in Python. So here we're defining args. And then the thing to the right of the dot is somehow created for us in this library up here. Whatever, in this case, it's the argparse library that created the stuff to the right of the dots. Up here, it was the requests library that created the stuff to the right of that dot and the right of that dot. Yes.
I feel like
Question is, these lines 31 and 32, what exactly are they doing? And the answer is that in order for Python to know like what are the valid things that somebody can type in down here on the terminal, you have to tell Python like what those things are. So up here I have the text and the example. So there's text and example right here. If I were to add something else like, I don't know, hello equals test like that, we get this error message that it doesn't know what to do with hello because it doesn't have a hello up here. If I change this to parser.add argument dash dash hello, then that hello would now be something that I can use down here. There would be an args.hello variable created, but I'm not actively using it right now. Did that answer the question? Yeah, so again, the main purpose of this is just to illustrate that there are many different ways of getting text into Python, but this is going to be the one that we'll really be focusing on.
Do
Jackson?
you have a one that you recommend using for what we're doing, like on the simple scale, what's the best one?
When you say what's the best one to be using, you're saying what's the best way of getting information into Python?
Yeah, like different methods. Would you rather do the requests or the argparse in terms of doing the more, I guess, the simple stuff that we're doing?
Yeah, so the question is, so there's 4 different ways of getting information into Python. Which ones do we use? And the answer depends on where the information is at that you're trying to work with. So here the information is located on the internet at this URL. So the requests library is the only thing to use to get information from the internet. If the information is contained in a file somewhere, then the open function and with the f.read, that's the only thing to do to get things into a file. And if the information is sitting on the command line somehow, then this is the way to get access to that information. When do we have information sitting on the command line? We'll see that in a little bit. So we'll see like the motivating example of why we want to use argparse here in a little bit. But at this point, the important thing is just that all of these get information from different locations to Python. Okay, and so then the next thing is like actually processing the text. And again, I have text one everywhere. So we've seen 2 methods of processing text so far. That we've seen how you can use string functions, and we've seen how you can use this JSON.loads. So we're going to start with these string functions. And again, I'm going to open up in interactive Python to see how to work with this a little bit more flexibly. So Python 3, if I just do notes.py like I've been doing, then this is not going to open interactive Python. It's just going to run the file and not let me run Python code. But if I add the -i between Python 3 and notes.py, so note not a -i here, that won't work. If I do that, then it gives me an error message. But if I add the -i right here, then after it runs, it drops me into interactive Python. And again, I know I'm in interactive Python because I have the 3 greater than signs down here. And now I can just run my commands directly like this. So here, this line 53, used this text.replace function, replaced the Draculas with Isbiki. And so our string literal, which was way up here, originally contained ebook of Dracula. Now it says ebook of Isbiki. And I can do that with all of my strings. It doesn't matter how I got the string loaded. So I have text2 is a really long string like that. So let's maybe make it a little bit shorter so that I can think about it a little bit. So let's do text2 colon 100, just see the first 100 letters of that. So it's the very beginning of an HTML document. It's different than our text1 variable. Because it's loaded from a file, it has a whole bunch of stuff in it. But on this text2, I can, here we've seen that I can do a slice. I can do replacing if I wanted to change, say, like w3.org.replace w3.org with something else, like, I don't know, google.com. Do that, and now it's done the replacing in there. And so it doesn't matter like how I loaded this information into Python. Here I'm getting it from, again, text2 came from a file. Text1 didn't. Text1 was just a string, plain by itself, and both of them I'm able to use my string operations on. Text3 also came from the internet. Text3, the same as, or pretty much the same as my Dracula.html file. And this one I can also, if we have our w3.org, I can replace that with w3.org, google.com, and everything still totally works. So this string type is like a, I don't know, a common place that you want to get to whenever you're loading information from a different source. If you can get it to a string, then you can do a bunch of stuff with it. So anytime you're trying to load a new type of data, your goal should be to somehow get it to a string, and then you can do whatever string manipulations you want with it. Yes. Okay, so in this project 2 that you're working on, you've seen more complicated ways of working with strings, in particular using JSON to convert the string that contained lots of data in it into a more complicated Python type. And none of these files that we have up above are valid JSON data in any form. So if I were to uncomment this code and rerun this file, then we're going to get an error message about that's not valid JSON, so it's not going to work. Oh, or maybe not. I have to save it up there for it to do that. So, oh, and I also have to import JSON, I guess. I knew I had to import JSON because it told me that the name error right here, named JSON, is not defined. JSON here, the thing to the left of the dot, not defined. And so by importing it, it gives me all the stuff to the right of the dot, all the stuff that's part of JSON. And we're getting these JSON decode errors. This means that whatever the contents of this string right here is, that it's not a valid JSON document, and so it can't do this decoding. And there's lots of different types of files. And again, all these files, most of them are interpreted as text. And so there's lots of ways of interpreting text into interesting formats. And so today we're going to talk about a third way of doing this, and that's this BS4 library. So this library makes HTML strings searchable using CSS selectors. So the very first thing we covered in this class way, way long time ago. Again, BS4, so BS stands for Beautiful Soup, is not built into Python, and so you'll have to install it using a command like this. And then once you've done that, then you'll have access to this Beautiful Soup library, and you can do a whole bunch of interesting things with it. Let's come down here, rerun our notes.py in interactive mode, and then we'll play around with this beautiful soup library to see sort of what we can do with it. That to do. And now, so this, when I have soup.select, the thing inside of here is going to be my the CSS selector. So up here, if we look at text one has a single HTML tag inside of it like this single title tag. And so if I have a CSS selector title, this will match this title tag right here. And this will be the thing that Beautiful Soup is able to find for us. So if I do soup.select, it's going to search through text1 because the soup variable was defined with this Beautiful Soup function on text1. And if we search for the title tag, then we get a list with a single entry in it that contains that one title tag. But if we did soup.select of, I don't know, look for an A tag, then we're going to get an empty list out because there's, we're just looking at text1. There's obviously no A tags in this very, very short HTML string right here. So this isn't a super interesting HTML string to look at, but we have some more interesting HTML to look at in these like text2 and text3 variables. Again, text2 taken from a file, text3 taken from the internet. We don't care the source of these strings at all. We can use Beautiful Soup on either of them the exact same way because they're both, we do type of text2, we get a string, and if we do type of text3, we get a string. So all the same functions work for both of these two variables, even though one was gotten from a file and one gotten from the internet. Again, it doesn't matter where you got your information from, you can always use the exact same string functions. And now we have this new string function, Beautiful Soup, which lets us apply CSS selectors. So let's do this. We'll create a new soup, call it soup2 equals beautiful SOUP, there we go, of pass in text2 HTML.parser like this. And it took, I don't know, half a second because it's reading through this entire string right here, processing it. And now if I do soup2.select, find the title in there, well, this is what the title of that giant HTML text right here is. Or if I want to find, say, all of the A tags, then here's a list of all of the A tags. If I wanted to find, maybe are there div tags? Oh, there's a lot of div information inside of here. If I wanted to, okay, let's go back to the A tags. Notice that the output here is a list. If I want to know, well, how many A tags are there? I can use whatever list functions I want, like the length here, and see, okay, there are 59 A tags inside of my text2. I know that they're inside of text2, again, because my soup2 was defined like this. Soup2 equals Beautiful Soup text2. And so when I did soup2.select A, it's searching through this text2 string to find all the A tags. Question?
In interactive Python, if you get like ... is that supposed to mean like it's loading, or what exactly is that?
Question is, in interactive Python, what does ... mean? Let's say I do something like 1 plus opening parenthesis like this. Then Python, it sees the opening parenthesis and it says, hey, where's your closing parenthesis? I can't end this line yet. I need to know, what are you adding to this one over here? So maybe 2 times 3 right here, closing parenthesis, and then it evaluates this as if it was a single line. So 2 times 3 is 6, plus 1, 7. If you have string literals, then it's not going to go onto the ... The most common way of accidentally getting onto the ... is these parentheses. It can also happen if you have, say, like if statements, if true, then it'll put you onto the next line saying, okay, what's inside this if statement? You have to indent. Let's print hello, and then hit enter again. This true is true, so it goes inside here and prints hello. But so the ... just means that Python needs somehow more information about this previous line in order to evaluate that line. Good question. Any other questions at this point?
In terms of like beautiful soup, is there a reason why it's called that? Can you use something else, or do you have to use that exact select? Is that what it's just called? Is it just called beautiful soup?
This right here is just called beautiful soup, and it has to be beautiful soup. Yeah, and then it's traditional to whatever the output of the beautiful soup function is to just call that soup. You generally have one of these in your Python code.
Are you able to do something where it's like from BS4 import beautiful soup as like or something?
So it's possible to yes, nobody does that. Yeah, so this is sort of the standard like invocation of how people use beautiful soup. You'll notice that, yeah, so here we're using the pattern of like from BS4 import beautiful soup. We could, something that you'll sometimes see people do is just import BS4, and then down here, BS4 dot beautiful soup. This is entirely equivalent to what we had above. For beautiful soup, it's traditional to have this be the way that you import it. And for the other libraries like the requests library or argparse, it's traditional to import it without the from clause. Yeah, so that's, everybody will look at you weird if you do something different than this to get access to beautiful soup, or do something different than the stuff above to get access to requests. Okay, and now, so yeah, so we saw, okay, there's this soup2 that we created from, we created soup2, beautiful soup from text2, HTML.parser like this. We can do the same thing for the text3. So getting it from the internet, and then again, text3 from the internet, text2 from a file, and then we still have access to text3 dot select, say title like that. Oops, not text3, soup dot select. So up dot select title, and there we go. And or if we want to get all the A tags. Text3, what is text3? Soup3 dot select A. That's what I call it. And there we go. Soup3, there we go. There's a bunch of A tags. You get the length of that, and there's 59 inside of the soup3. Got them from the internet, same file that was on the hard drive, so we should get the same number here. But again, the point of this is that, or one of the main confusions that students have is sometimes, I know how to work with strings, I know how to work with files. Now it seems like we're doing something totally different by working with web pages from the internet, but nothing is different about this except these lines up here, how you actually load the data in. Once you've loaded the data in, it doesn't matter where it comes from, you can do anything that you want to it. Any questions at this point? Yes.
So when you search for the A tags,
yes,
big long list. So are I don't see the quotes, the items in this, are those strings in there?
Yeah, so this is a fantastic question. Question is that when I do this soup.select of this A tag like this, I know this is a list that's coming out because I see the square brackets here, but then this looks like it should be a string, but it's not actually a string because I don't see any quotation marks. What's the deal with that? And so since this is a list, I know I can use my slicing sort of things like this to get access to one of the elements of it. And the question is like, so what is this thing? So if we look at the type here like this, then this thing has this weird type that it is what's called a tag. And so it has different things that we can do to it. Let's see. So like here, if this is what the actual like contents of that tag are, if I wanted to get this text between the two tags like this, I can do a .text at the end and it extracts this piece of information right here. And yeah, so it's a little bit more powerful than a string. It's just being displayed sort of as a string, but sort of not as a string up here. Does that answer your question? Yeah, good question. And that's a doubly good question because like as a programmer, as a hacker, these sort of small details matter to our code. So that's a great thing to be paying attention to. Like I was expecting a quotation mark there. Why is there not a quotation mark there? Great question. Okay, so what we're going to do next, we're going to create an entire program from scratch that downloads web pages from the internet and saves them to our file, to our computer. This is sort of like one of the standard default programs that everybody has to write at some point for learning how to just work with the internet. And so we'll do that together in class here. And that'll illustrate some of the differences of like when you want to use each of these file input output systems. So what I'm going to do, right click here and do new file, and we'll call this wget.py. For these big programs, it's traditional to have a doc string at the very top of the program that tells us what our program is going to do. So a wget program is a program that gets information from the web. So the W stands for web. So it's like wget. And in order for us to know what is the name of the URL that we want to download, what is the URL that we want to download, we'll first get the URL to download from the command line. Anytime we're getting something from the command line, that means that we should use the argparse library. So over here, find out where the argparse information is. I'm just going to copy and paste this. This is the sort of thing that nobody has memorized about how to use. It's always a copy and paste to get the magic invocation that you want. And I want to get a URL. And so down here, I'll say URL equals args.url, and then just print URL equals comma URL like that. And then down here, let's leave interactive Python mode and just try out this program so far, Python 3, wget.py -- equals, and let's try google.com to start with. And so we got this information from google.com, and or we got this information from the terminal that is google.com, and we put it into this variable URL right here. This wget program, we want it to be somehow super generic that works with any URL possible. And so we want the user to be able to type in whatever URL they want to download. And so that's why we have this, that's why we're using the command line to do that. Anytime there's something relatively short that we think the user might be typing in, the argparse command line is a good way to handle that in a generic way, so that we don't have to write one program for every web page that somebody might want to download, but can use the same program to download any web page, just they pass in the web page like this. Okay, so now that we have the URL, we need to actually download the URL. So download the URL. And again, I don't need to have that memorized. I can always just look up, okay, how do I get information from the internet? Well, this is the method 3 right here. So I'll just copy and paste that over into this code right here. And then instead of having this be my hard-coded URL, I can just delete that and we'll have request.get URL right here. This URL is what was passed in on the command line. And then my text variable right here will be whatever the contents of that particular URL is. Save that, come down here, up arrow, rerun it. And oh no, I'm getting an error message. It says missing schema, invalid URL, google.com. Anytime with this requests library, when you're passing in a URL to this function, you have to have so what's called a schema here. The schema is the http:/ or https:/ in front of your URL. So here, https:/ google.com. This, anytime you see a message saying invalid schema somehow or invalid URL with missing schema, it means that you're missing this key part of the URL right here. Okay, enter. Then now we don't have that error message, and this text right here would be the text of whatever was contained in this web page. Any questions at this point? Yes.
For google.com, or like the HTTP part, I get that it's an unrecognized argument. Maybe my dash is different. What dash do you press?
If you're getting something that looks like unrecognized arguments, then whatever you have right here does not match whatever you have up here. So it should be the dash on an American keyboard. It's the minus sign right next to the numbers. It's the same minus, whatever you use for minus in Python. And here I have URL right here. So that's why down here it has to match exactly URL down here in order for it to work. Okay.
As just like a side question, for I've noticed like the U, so like untracked or like untraced. What does that mean?
Notice the U untraced.
On the left side, in the library, where it's like the actual name of the Python file, and then it has the green U.
Over here somewhere?
Yeah, with the wget.py.
That
What is
U.
that?
Good question. Super complicated,
Okay.
not at all related.
Cool.
Yep. Has to do with the fact that all of this is posted on GitHub. Okay, so now our last form of input and output. Somehow we're going to save all this information to a file on the hard drive. And so now save the file. Anytime we're saving things, that's the open function in Python. So let's do an open our file name. We're going to write to it, and we'll have our encoding being UTF-8 like that. So with open as F, and then F dot write text. So we're writing, so we're using a W here instead of an F. I have the file name right here that I'm passing in to the open function, what I want, like the location of the thing that I want to write to. Let's for now just say file name equals web page like that. And now when I run all of this together, it'll use all three of our, we actually have all four of our string input methods here because we have hard-coded things as well, string literals. And if I press the up arrow and run it, no error messages, and you can see that this web page suddenly appeared over here. And if I click on that, then here's all the web information from google.com. And if I were to right-click that, copy the path, come over to Firefox and paste that in, then we'll see some version of google.com just without all the images and other things. Question.
When I run it, the text, when you do f.write text, my text is like a little squiggly line under it, and it says text not defined if you use text.
So up here, this is where I was defining text being response.text. And yeah, in the previous version of the file, this was text3 getting the thing from the URL. And I just changed it here to be text instead of text3 because there's only one text variable that we care about in this file right here. Good question. Any other questions at this point? Yeah, how to get this to Firefox? Over here on the file, right-click, copy path, and then you can go over to Firefox and just Control-V, paste that up there, and you can see now whatever it is, the HTML that you downloaded. So here's downloading google.com. Our program is fully generic now. We don't have to write any more Python code to download a different URL. So let's now, I want to download my, but the Project Gutenberg Dracula. So let's Control-C that URL up here, come down over here, and I'll just paste that into my URL right here, the thing that I'm going to download, and I hit enter. It'll go ahead and do that download. There we go. And now that's stored in the web page, the new version of the thing downloaded, this new URL. And so if I come back over to Firefox and refresh over here with this web page, now it's giving me Dracula over here. Any questions so far? Okay. So one of the things that's really, I don't know, ugly about this program right now is that the output file name down here is always has to be like equal to web page. There's no way to make this a little bit more generic to download to a different location. And it's a very common thing to want to do is to download to a different location. And I don't want to have to edit the Python every time I want to have a new location. And so anytime I have these sort of hard-coded string literals in my Python programs, one of the things that I'll do is just make it an argument, add argument like this, and now dash file name, like what is the place that I want to download it as. And now down here, instead of just file name, I can do args.filename like this, and it'll be nice and generic that whatever file name down here I specify, I can save it to web page. So this looks like parser add argument. Thank you. Like that. Save that down here. Up arrow, rerun. And okay, no error message, saving it to web page. Maybe I actually wanted like webpage.html though, because it's an HTML file. And now if we look over here, webpage.html was created. But actually like Dracula.html is really the better name for this because it's got some sort of semantic meaning. And now up here we have this Dracula.html. And if I want to download Google, then I can say file name equals google.html. And over here, let's change this to google.com like that. And now download google.com to google.html. Any questions? So yes.
What's an argument again?
Question is, what exactly is an argument? And an argument has multiple meanings when you're programming. When you're talking about a program that you're running on the terminal, an argument is one of these things that you're passing in. So these are arguments. We have the URL argument and we have the file name argument. When you're talking about functions, an argument is the thing that you're passing into the function. So this get function right here has a URL argument, just one. The open function right here has these three arguments. And so an argument is a synonym with a parameter, is a synonym with an input to a function or a program. Anything that can have an input, we can call that input an argument.
So for parser to add argument, is that like a function of argparse and then it asks the user what they want for that?
Exactly. So the question is here, argparse, it has a bunch of functions built into it. The pattern of using those functions is you say parser equals argparse.argument parser, and then parser dot will give you access to those functions. One of those functions is add argument here, and this particular add argument adds these arguments down here. Does that answer the question? Good question. Yes.
One other thing is like, so I might know this, but like, do you do like Google HTML, you save as an HTML first, or is it once you run that, then it'll create that Google HTML?
Yeah, so the question is, did I have, so here I have my file name equals google.html. Did I somehow have to create google.html before running this program so it had a place to save it? And the answer is no. So right over here, you can see here's the location of google.html. Let's right click on this and go to delete. So there is no more google.html. And down here, if I just hit enter, then it will automatically create that for me. Excellent.
What is the, when you're opening and saving the file, what does the W represent? Because I've seen other letters there, before, R and other stuff.
Oh, right here, what is the W? So this parameter right here is called the mode that we're opening the file with, and the W stands for write. W equals write. We've seen the R for read. We've seen T for text mode meaning that automatically apply the encoding. And we've seen the B for binary or bytes, which means don't apply the encoding. Another one that's sometimes useful is X. So X means it's the same as write, but if the file already exists, throw an error. This can be useful for programs like this where, okay, maybe I want to download facebook.com, file name, we'll call it fb.html, hit enter. And the first time, like, okay, that it's successful, it's that's good. But maybe now I don't want, if I already have a file there, I don't want to accidentally overwrite it. And oops, if I change this W to an X, then when I run this, since that file already exists, we get this file exists error and saying that can't create this fb.html because it already exists. But if I were to change that fb to facebook.html, then it'll actually create it. Yes.
I might be getting confused with something else. I thought binary or bytes is beyond.
So all of these can be combined in different ways. So the question is, we've seen BR before. Why is B and R listed separately here? If you're doing something in binary mode with read, then it would be BR. If you're doing binary with, or sorry, if you're doing read with text, then it's RT. Here, text is sort of the implication, the automatic one that's applied. So this is equivalent to XT. It's the same thing. If I wanted to work manually with encodings, then I could do XB like this and change this encoding, do the text dot encode UTF-8 right here, and change this to Facebook2.html, and now that works. That answer the question?
Oh, wait, actually, just to clarify, so when you put the dot encode UTF-8 at the second line, that is still decoding, right? It's like text.
So the encoding converts from bytes to text. The decoding converts from text to bytes. Yeah. But yeah, this part right here, when you, at some point, we have to get bytes down into the original file. And so with the B mode, we have to pass a bytes to the write function. With text mode up here, it automatically applied this encoding for us. All great questions. Any other questions so far? Okay, so let's step back for a second and talk about why we're talking about this. Your next programming project is going to be a a web scraper, and you're going to have to write your own program that's going to somehow follow this basic outline, where you're going to have a argparse thing at the top here, specifying different arguments that are going to come in, like the URL and maybe an output file name somehow. You're going to have to download some things, and you're going to have to do some processing on that and then output to a file. And the specific thing that you'll be working on is eBay. You'll be scraping information from eBay, extracting what are the prices of various products, and then outputting that as a JSON file that contains all that pricing information. So we'll talk about the details of that assignment next time, but that's why we're talking about all of these different things right now. Yeah, we just have a few minutes left, so we'll do one last little tip with this argparse library right here. That down here, so yeah, right now I'm manually specifying this file name like this, but I know it was a little bit maybe more convenient before when I didn't have to type in the file name that I explicitly wanted. Maybe it makes sense every time the URL is something that I have to specify, because that's going to change every time. But the file name, maybe there should be a default file name. And so if I do something like this, don't put in the file name, then we're going to get a type error, invalid file none on our line 26. How do we figure out what's going on? Line 26 right here, args.filename. If you don't put in the file name down here, then the value is going to be none. So the easy way to handle this is that you can have a default argument or a default value for your argument, say default up here. Default equals downloaded webpage.html. And then if you don't specify like what's the name of the file name that's being downloaded, then it'll automatically save it to this location right here. So now down here with that default, I press the up arrow, rerun this, URL equals facebook.com, hit enter, put it in this downloaded web page over here. But now if I were to try this again, say with, let's go to Twitter now, twitter.com. We'll get this file exists error because the downloaded web page already exists right here. If I go and delete that, then now it'll work, downloading Twitter. If I run it again, now it's not going to work again because downloaded web page exists. So another thing that I can do to make it work is actually manually specify the file name equals twitter.html like that. And now it'll work again. But now twitter.html already exists, so now it won't work again. So yeah, it's a little bit, or one of the tricks with this argument parser that you can do to make your interface a little bit more ergonomic and user-friendly, where you don't have to specify all the different possible options that you might want. Henry?
Is there any way to make the download the name, the file name equivalent to the URL?
Oh yeah, so the question is, what if I wanted to somehow make the default based on the URL up here? And so if I don't have a default, the default is equal to none. The default, or the maybe better English way of saying that is if you don't specify a default and no file name on the command line, then the value none will be in args.filename. And so down here, I could say, change this back to file name. If not args.filename, then file name equals some function of my URL. So we could do something like args.url dot split on the slashes and take the last index of that. So it turns out that you can't have in any operating system, you can't have a slash inside your file name. So we can't actually include this schema in the file name. But if I split on the slashes and take the very last entry, that'll give me whatever's over here. So that'll give me twitter.com. So this would give me the twitter.com, else file name equals args.filename like this. And so we're now, processing that default option. So again, if not args.filename, this will check to see if it's equal to none. If it is none, then we'll do that processing. And here we run this, take out the file name like that. And down here, twitter.com was just created, but I can still do -- file name equals twitter.html.com.html if I wanted, and that'll work too. So the answer is yes, it's just a little bit more complicated.
Can you go back to the person part of the argparse section?
Yeah. So this is a good stopping point for us for today. Next class period, again, you have your quiz on the list comprehensions, and we will continue talking about this in the context of scraping information out of eBay. If you have any questions about anything, I'll stick around after class as long as people have questions, but otherwise, see you all on Wednesday.
Hello. I have a quick question about, so this is kind of related to what Henry was talking about, how you have to display